Okay, we are going to integrate sinh square x. And to do this, we can just use the power reduction formula. So let me write this down right here for you guys. So here we have the integral, and this is actually the same as 1/2 times -1 plus cosh of 2x, like this. And notice that this is very similar to the regular sign to the second power, right? But you just have to remember that this is actually a -1 right here, and we add cosh, and the input is 2x. And of course, we have the 1/2 all the way in the front. Okay, now after the power reduction formula, we can put the 1/2 in the front, and then open the parentheses for the result of integration. Integrating -1, we get -x. Integrating cosh, we get positive sinh. So I will put down plus sinh, and the input is 2x, so I'll just keep it. And because the derivative of 2x is just the number 2, so we can just go ahead and divide it by 2. Remember, this only works if you are just dividing by a number. So yeah, that's why we can do it like this. So in the end, of course, we can just distribute the 1/2. So we get -1/2 x and plus 1/4 sinh of 2x, and we're done. Of course, don't forget the plus c. And with that, we are done. Okay, we are going to integrate sinh to a third power x. Well, this is an R power situation, so it's very similar to the idea when we have to integrate the original sign to a third power x. Well, this is what we are going to do. Let me write this down. This is the integral, and I will just break it down as sinh square x times sinh to the first power x dx. And the reason I want to do this is because we can actually write this in terms of cosh. So let's go ahead and think about it. Well, remember that, let me put it down right here for you guys. Cosh square x minus sinh square x. This right here is nicely equal to 1, right? So if you want to get the sinh square x by itself, all we have to do is move this here and move the 1 there. In another word, sinh square x is equal to cosh square x minus 1, like this. So we can replace this now right here, and we end up with the integral cosh square x minus 1 in the parentheses, and then we have the sinh x on the outside. And the best part of doing this is that we can just do a u-sub now. So just go ahead and let u equal to cosh to the first power only, okay? Cosh x. And when we differentiate cosh x, we nicely get positive sinh x dx. Remember, this is the hyperbolic version. Differentiating cosh x, we get positive sinh x, okay? Now, you see this right here is exactly that, which is the du. So we can go to the u world real quick. This right here gives us the integral. This right here is the u. So we have u squared, and then minus 1. And then this right here is the du. So now that's all we have to do. Now, integrating u squared in the u world, we get 1/3 u to the third power. And then integrating 1 in the u world, we just get u. So we have the minus of u right here. That's pretty much it. And we just have to go back to the x world. Put this back, put this back. So we have 1/3. And we have cosh to the third power x. And then minus cosh x, like this. In the end, don't forget the plus c. So we will put down the plus c. And this right here, yes, it's it. Okay, here we are going to integrate cosh x over 1 plus sinh square x. Well, notice that because we have cosh and sinh in the same integral, right? So this is good. We have to remember that the derivative of sinh x will give us cosh x, and we happen to have the cosh x on the top. So this is really good. Because now we can just take a u-sub, let u equal to just sinh to the first power. And you'll see, differentiating both sides, we will get cosh x dx. So in another word, this right here, all this is exactly our du. So we have the integral here, and we have the 1, and let me put the du on the side. And here we have the 1 plus sinh is our u, so we have u squared here, like this. And when we integrate 1 over 1 plus u squared in the u world, we get what? inverse tangent. And remember, this right here is just the original version of the inverse tangent. There's no h right here, okay? And then the input is u. And in the end, of course, we can just finish this because this is inverse tangent. And the u is the what? The hyperbolic sine function. So we have the sinh x like this, and we are done. So put a plus c, and this is it. The strategy for this one is very similar to how you will integrate the original tangent x. What we can do for this case is that let's write it as sinh x over cosh x, and we're just dealing with the hyperbolic version, right? And then we can of course do a u-sub. I will let u equal to the bottom function, which is cosh x, and then differentiating cosh. Remember, the derivative cosh is actually positive sinh. So this right here is just positive sinh x, like this, right? And now as we can see, this right here is nicely equal to our du, and then on the bottom is of course that's a u. So we get the integral 1 over u, and all that is our du, so let's put it on the side. And then when we integrate 1 over u, we get natural log of u and the absolute value like this, right? So that's pretty much it. But we are going to go back to the x world, so put this in, so we actually get natural log, and the input is actually cosh x. Now, the truth is, for cosh x, this right here is always positive, so you don't need to use the absolute value. You can just put down a parentheses, and we are done. So we can just put down a plus c, and that's it, right? Cosh x is always positive because this is e to the x plus e to the negative x all over 2. So it's always positive, right? Now, let's have a look with the hyperbolic version of the secant. You might want to try with the way that you will do it with the integral of secant x. But for this one, we are going to approach like that, kind of, you'll see. Anyway, this right here is the integral. For the hyperbolic secant, this is just 1 over cosh x, that's okay, dx. And now, the problem with this one is that we do not have the top to be sinh x to help us out, so do not try to do u-sub right now. It's not going to help yet, right? Well, we want to have more things to work with. Just like the traditional version, when you have an integral, sine and cosine, they are best friends. When we have the hyperbolic version, sinh and cosh, they are best friends. If we have cosh right here now, we want to produce sinh to help us out. And to do that, in fact, I'm not going to multiply sinh on the top and also on the bottom. Because on the bottom, if I have sinh x times cosh x, well, that's an identity that I don't know if that will be any good for us. So I will actually multiply this by cosh x on the bottom and also on the top, because that way I can produce cosh square x on the bottom, and we do know a much better identity to help us out for that. Well, have a look here. This is the integral. On the top is cosh x over, on the bottom, notice that this is just cosh square x. And let me write this down right here for you guys. Recall that cosh square x minus sinh, this is an h, square x, this right here will give us 1, right? And of course, we can just add this on both sides. So we can say cosh square x is equal to 1 plus sinh square x. Much better. I will put this down right here, and you see we still have what? This right here, we still have the sinh and cosh. That will help each other out. Very nice. And I will just put down the dx right here. And then, of course, we can do u-sub. I'm going to let u equal to just sinh to the first power. And the reason is because when I differentiate this, I will get positive cosh x. And you see, this is just to the first power. This right here, it's exactly what we have on the top. That's the du right here. Very nice. So now this is the integral. I figure I should also put the du right here just to be consistent. But anyway, this right here is the du. I'll put it on the side. And here we have 1 on the top over 1 plus sinh is our u. So I'll just put on u and then square that. And then all this is the du. Now, when we integrate 1 over 1 plus u squared in the u world, this right here gives us the inverse tangent notice this is the original version, okay? The inverse tangent, the regular version, right? The original version. And the input here is u, like this. However, u is sinh, so I'll just put that down. So in the end, we have inverse tangent of sinh x, like this. And what's that? We are done. So this is it. Okay, I will show you guys two ways to integrate tanh to the third power x. And here we go. For the first way, I will just break this down as tanh to the first power x times tanh to the second power x dx. And the reason I want to do this is because we have some identities that we can use for the tanh square x. So let me write this down right here for you guys. Perhaps I'll just write it down right here. Well, as we all know, cosh square x minus sinh square x, this right here is actually equal to 1, right? So this is the main identity for the hyperbolic trig functions. And to get tanh square out of this, we can just look at everything and divide everybody by cosh square x real quick. And that will be very nice. And then you'll see this right here is just equal to 1. And this right here is minus, and this is, by definition, tanh square x. And this right here is the hyperbolic version of the secant square x, like that. Well, to get tanh square, we can just move this to the other side and move this to here. So we actually get 1 minus hyperbolic secant square x equals, move this here, so it's positive tanh square. So this is what we are going to use for this one, right? So now we know this right here is equal to that. So I will just put this down on the top. 1 minus hyperbolic secant square x. And then what we are going to do is we can just distribute this and then break it down into two integrals. So now, here we go. This right here will give us integral this times that, which is just tanh x, like this. And I will close that by putting on the dx. And then for the next one, this times that, it's a minus on the outside. And we have the integral, and we have this times that, which is tanh x times the hyperbolic version of the secant square x dx. In fact, we have done this one already. You guys can check out my other video if you need to. And this right here, we can use a u-sub, because if we let u equal to tanh x, we see du is precisely this, hyperbolic secant square x dx. So we can finish this. Now, the answer for this one is natural log parentheses, because the inside, the cosh x, it's always positive. So this is enough, right? Parentheses, you don't need absolute value. And for second one, I will just put down minus. You see this right here is the u, and this right here is the du. So integrating u in the u world will give us 1/2 u squared. So this is 1/2. U is tanh, and then I will square that, and then of course we have the x. And what's that? We are done. So this is the first possible answers for the integral of tanh to a third power. Now, or if you would like, you can do the following as well. Integral tanh to the third power x dx. Well, tanh is the same as saying sinh x over cosh x. So we can look at this as sinh to the third power x over cosh to the third power x dx. Ideally, we are going to use u-sub. Hopefully, we can let u equal to cosh. So in that case, we should have a sinh x on the side to help us out. Therefore, I will break this down. This is the integral. Here we will have cosh square to the third power x. But for the top, let me just write it as sinh square x. But I need another one. And let me just put it down on the side. And we have the dx right here. Okay. Now, look at this. We have sinh square x. And remember, we have this right here. Remember that when we have cosh square x minus sinh square x, this is equal to 1. And if you just want to get a sinh square x by itself, we can just move this to the other side and move the 1 to here. So we can see cosh square x minus 1 is equal to sinh square x, isn't it? So I will replace this right here with that, and therefore we are looking at this. This is, let me just write it down again. Sinh square is equal to cosh square x minus 1. And then we have this over cosh third power x, and then this is sinh x dx, like this. Okay? Now we can do some u-sub. And let me just write this down for you guys. I'm going to let u equal to cosh x, just the first power, because when we differentiate, we get positive sinh x dx. Remember, when we differentiate cosh x, we get positive sinh x, right? So this is the hyperbolic version for that, right? So now we'll see this right here. We will have the integral. This is the u square minus 1 over, this is u to the third power. And then this right here is precisely our du. So this is what we have. Now, to take care of the business here, we can look at this as integral u squared over u to the third power. That's 1 over u only. And then for the second part, we have the minus u to the third power on the bottom. So we'll write it as u to the negative 3, like this. For the first one, well, we can just do natural log of the input, which is the u. And for this one, we will have to add 1, which is going to give us negative 2, divided by the new power. So we'll have 1 over negative 2 like this. And that will give us a positive now. And this is positive 1/2. Like that, right? And then we have u to the negative 2. Let me just put this down right here for you guys. Lastly, u is what? U is cosh. So for the first one, we have natural log, and earlier actually I put on absolute value, but after we know the input is cosh, so I can put down just cosh x with a parentheses, because cosh x is always positive, so this is good. And then I will write down plus 1 over 2 on here, and you see that we have u squared on the bottom, and u is cosh, so I can just put down cosh square like this, and then the x. And if you would like, you see 1 over cosh square is the same as the secant, the hyperbolic version, so you can write this down as 1/2. Again, 1 over the cosh is the secant, hyperbolic version of that, okay, secant squares. Hyperbolic version secant square x, like this. And then in the end, we're done, plus c. Technically, you see this and that, they are different. But this is technically c1 and c2 because they are just off by a constant for the integration. And the idea is that if you graph this and if you graph that, you will see that it's just off by a vertical shift. So that's why for the function part, both of the function parts, when you differentiate, you will end up with 10 to the third power. So both of them are correct. So yeah, either way that you like, and leave a comment down below if you like. Okay, we are going to integrate x times hyperbolic secant square x. And to do this, we can actually use integration by parts. Namely, the DI setup on the side, right? So put on plus minus and one more, you'll see why. I am going to integrate hyperbolic secant square x, and I will be differentiating x because this right here is actually pretty straightforward. The derivative of tanh will give us this. So when we integrate this, we get tanh x, just like that, right? And when we differentiate x, we just get 1. And now, can we keep going? Sure, right? Differentiating 1, we get 0. That's good. And can we keep going? Can we integrate tanh x? Yes. And the answer for that is natural log of cosh x. You don't need absolute value because cosh is always positive. Therefore, we're done because we have the 0 in the D column. So that means the answer is just this times this times that. Yeah, that's it. So here we go. Let me just write it down. The first part is x times tanh x. And then don't forget the minus here. So it's this times that. So we have to minus ln parentheses cosh x. And Yeah, we are done. Put plus c. So integration by parts still works even for hyperbolic versions. And okay, we're going to integrate inverse tanh x over 1 minus x squared. This run is actually not so bad because one u substitution will finish this. Because the derivative of inverse tanh x is precisely 1 over 1 minus x squared. So that's very nice. So of course, I'll write this down right here for you guys. Take u to be the inverse hyperbolic tangent x and differentiate this real quick. We get 1 over 1 minus x squared dx. So as you can see, this part, well, I should do like this. This part will give us the du. So all in all, we just have the integral. On the top is the u. And all this is the du. So we just have u du like that. And now integrating u in the u world, we just get 1/2 u squared. And of course, you can put this down here now. So we have 1/2 parentheses inverse hyperbolic tangent of x and square that. So that's it. Put a plus c like this. Alright? Okay. Before we go, let me just tell you guys that. I'll just tell you, don't ever, right? When you have an inverse trig function or inverse hyperbolic trig function raised to a certain power, don't ever multiply this and that together. Don't ever write, seriously just don't ever write things like -2 like this. Don't ever put on -2, right? Don't ever do that because that will be extremely confusing. I know this inverse notation is confusing enough already. Don't ever do that, right? So be sure you use the parentheses and just say inverse hyperbolic tangent of x squared, and of course the 1/2, and of course the constant, and of course we are done.